Today, we're going to pull back the curtain and go inside the high-stakes world of keeping your lights on. We're talking about the digital brain that manages the absolutely immense, complex, and vital network we all depend on, the power grid. So let's see how it all works when the pressure is really on.
Really think about that for a second. A massive storm is rolling in. Thousands of homes are losing power every single minute. How on earth do you manage that kind of chaos, restore service, and keep people safe? Well, that is the fundamental question that systems like this are designed to answer. And look, the challenge here is just huge. Today's power grid isn't some simple network of poles and wires anymore. It's a living, breathing ecosystem that's under constant threat, from crazy weather to equipment just giving out, and the growing complexity of all these new energy sources. Managing the grid is basically like being an air traffic controller for our entire energy supply. Every single second, you have to perfectly balance supply and demand across thousands of miles. One wrong move, one missed signal, and the consequences can be absolutely massive.
So, how do you even begin to control a system this complex? Well, it all starts with a simple, powerful principle. You just can't manage what you can't see. The whole foundation of modern grid management is total, uncompromising visibility. Before you can even think about fixing a problem or sending a crew out or planning for the future, you have got to have a single, unified view of the entire network. That is step one, the absolute foundation.
And when we say everything, we mean everything. From the gigantic substations that are like the hearts of the grid, all the way down to the individual feeders branching out to your street, and every single switch that controls where the power goes. And this is that window. The Oracle Network Management System Viewer is the operator's command center. It takes millions of disconnected data points and magically transforms them into a clear, interactive map of the entire electrical system. And this is where you really start to see the sheer power that an operator has at their fingertips. They can trace the exact path of electricity through the network, instantly identify any device with special symbols, or switch between a real-world map and a simple schematic. They can even use something called feeder focus to just zero in on one critical power line. It's all about getting the right information right now.
Okay, so seeing the grid is one thing, but the real test, that comes when things go horribly wrong. Let's look at how this system shifts gears from just monitoring things to actively managing a full-blown crisis. The second an outage hits, a very precise sequence just kicks into gear. First, all the customer calls start flooding in, and the system automatically groups them, looking for patterns. Right away, it predicts the most likely piece of equipment that failed. Then, as crews get on site, their reports are organized by damage assessment tools. This lets the system dispatch the right crews with the right gear. And all the while, operators back in the control room are monitoring the entire restoration from start to finish. And you gotta understand that link between the control room and the folks on the ground, it's absolutely critical. The crew that's out there trying to get your power back on isn't flying blind. They're getting real-time data, the address, how many customers are out, the device history, sent straight to their tablet or phone. That seamless flow of info is what makes restoration faster and, most importantly, safer.
During a major storm, all that chaos gets funneled into a single, organized dashboard. Operators can zoom in on specific zones to focus their efforts. The storm report gives them a live tally of how many devices are out and how many customers are affected. And the summary info panel gives them that crucial big picture, the estimated total repair time and how many crews they need for each type of job. It literally brings order to the storm.
But it's not all about emergencies. A huge part of managing the grid is the proactive, planned work, all the maintenance and upgrades that actually prevent outages from happening in the first place. And for this, precision and safety are absolutely everything.
Here, every single action is meticulously planned and tracked. Operators use digital switching sheets, which are basically step-by-step recipes for safely de-energizing a power line for maintenance. The system can even generate the go-back steps automatically to reverse the whole process safely. Digital safety tags are placed on equipment, and every single click is recorded in an audit log that can never be changed. There is just zero room for error.
All right, now we're moving from planned human action into the really cool, futuristic stuff, the automated intelligence that powers the modern smart grid. This is where the system actually starts to think for itself. So first, let's just quickly demystify a key term, SCADA. The easiest way to think about it is as the grid's nervous system.
It's this huge network of sensors that are constantly feeding real-time data, voltage, current, whether a switch is open or closed, back into the main NMS brain. It's the live data stream that all the advanced smarts are built on.
And that leads us to this, FLISAR. And honestly, this is just incredible. When a fault happens, say a tree falls on a line, FLISAR is the automated first responder. It automatically locates the fault, electronically isolates that one broken section of the grid, and then it intelligently reroutes power from other places to get service back on for everyone around the fault. What's that mean for you? It means a tree branch might cause your lights to flicker for 1 second instead of you being in the dark for 4 hours. And finally, there's DERMS. As we all add more solar panels, wind turbines, and EV chargers to the grid, things can get really complicated. DERMS is the digital coordinator, the conductor of the orchestra for all of these distributed energy resources. It makes sure they all work together to support the grid, not destabilize it. It is the absolute key to making our renewable energy future actually work.
And these advanced systems can basically run in 2 modes. In manual mode, the system does all the heavy lifting, the complex analysis, and then it recommends an optimal plan. But a human operator has the final say and pushes the button. In automatic mode, the system is authorized not only to find the best solution, but to execute it instantly, all on its own, allowing for real-time automated adjustments to the grid.
So we've seen this unbelievably powerful mission-critical system, but I want to end on what might be the most surprising part of this entire story, what it's all built on.
What kind of super secret, lockdown, proprietary technology do you think you'd need to run something this important? Well, the answer might not be what you expect at all.
It turns out this entire system stands on the shoulders of giants. It's built on a foundation of powerful, respected open-source technologies. We're talking about code governed by the Apache and MIT licenses, foundational tools like Python, and brilliant libraries like SQLite and the Chromium Embedded Framework. This enterprise-grade nerve center is powered by a global community of developers. And deep inside the licensing documents for one of its core components, SQLite, you don't find a scary legal notice. You find this, a blessing. It's just a powerful reminder that even the most complex and critical technology is, at its heart, a deeply human thing. And this brings us to our final question. We've seen how a digital nerve center can manage the grid of today, but as everything from our cars to our homes goes electric, the pressure is only going to grow. What new intelligence, what new level of automation is going to be needed to power the world of tomorrow?